Hello my dear students, I am B S Pandey, here your physics lecturer. Today we will start the new chapter. It is mechanics, that is the Newton's laws of motion. Okay, so in the chapter Newton's laws of motion, it is very important to study about the force. First, it is a 21st lecture. #21 of Newton's laws of motion, that is the NLM. Newton's laws of motion. Now, my dear student, in this chapter we will start with the introduction of inertia that you have been studied already in your standard 9th. I will give you a very short clip to understand the inertia and laws of inertia, as we have been studied in well manner about this inertia, and then we will come to the force and laws of motion. Okay, so the first topic, it will be the inertia. What is the inertia? So you have studied the inertia is the property of any body by which that body try to remain in its actual state of rest or uniform motion until unless any external unbalanced force going to disturb that body. Okay, so this is the inertia. In fact, all the inertia concept, the laws of inertia which was given by Galileo, was taken as the first law of motion, which was given by the Sir Isaac Newton. Okay, so this is the inertia, and we are having the three laws of inertia: inertia of rest, motion, and inertia of direction. Then we'll come to the concept of force. Okay, that we have to study in this chapter. It is force. Even in standard 8th, you used to give the definition of the force. The force can do this thing, that thing, and after accumulation you give the introduction and the definition of the force, that force is this thing. Okay, so we know that the force is a vector quantity. Of course, it is a vector quantity, and we also know the SI unit of force and the different unit of force. But let me recall here the units of force. Although you know, I know that you know very well, but let me recall here the unit of force. SI unit, it is Newton itself. The capital N we use to represent the SI unit. CGS, it is dyne. And this Newton, my dear students, in MK system you used to write kg meter per second square, and in CGS this can be written as gram. For the kg we used to write the gram centimeter per second square. So this is the CGS unit. There is a relation between this SI unit and CGS unit also, that 1 Newton, it is equivalent to the 10 to the power 5 dyne. Okay, and the third one, it is the gravitational unit. Gravitational unit, and it is kg weight or gram weight. Okay, so this kg weight is equivalent to the weight of 1 kg of mass. That's why it is the kg weight we used to say. Might be you will find a question, it is written the 5 kg weight of this force is acting towards this and that. Okay, so the kg weight is also very important to understand. It is the weight, it is the force, or the force equivalent to the weight of 1 kg of mass. That's why this is called the kg weight. Okay, and how much it is? We know that the weight is m times g. So 1 kg and the g, it is 9.8 Newton. So the 1 kg weight will be equals to 9.8 Newton. Okay, so these three are the unit of force. Okay, my dear students. Now, after knowing the unit of force, we will come to the discussion of inertia and laws of inertia. After that, it was considered the next quantity. So let's have a look over this small clip. Okay, look at it.
That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is the tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is the tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground after being kicked does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction.
As you have seen the video clip, it is explained there the laws of inertia. Okay, now come to the Newton's first law, motion. Although it has been explained in that clip also, I got that clip from internet for you to just explain a few concepts using the videos. Newton's first law. And you know that very well about this Newton's first law, but basically I will explain you here the Newton's first law mathematical form. Okay, you have studied in standard 9 the Newton's first law, but here mathematically I will explain you the Newton's first law. But what we have been studying in standard 9, my dear student, it was everybody in this universe try to maintain its state of rest or uniform motion until unless any external unbalanced force act on it. Or in very well manner you can say that everybody in this universe try to maintain its state of rest, uniform motion or direction of motion until unless any external unbalanced force act on it. Okay, my dear students. So we are going to write here the mathematical form of that Newton's first law. Suppose you are having a body over here of some mass m. Alright, it is kept over the surface. It is the surface, rough surface, my dear students, and this body is in rest. So it remain in rest until unless any external unbalanced force act on it. Mathematically we can write this one, if this is our axis x, y, and this is the z axis, then we can write the sum of forces, if sum of forces along the x-axis or y-axis or z-axis is 0, then the body remain its actual state of rest or motion or uniform direction. So this is the mathematical form, and this is very, very important, and this is also called the condition of equilibrium of body. Remember, the two things you have to study, my dear students, the condition of equilibrium of body and the condition of equilibrium of particle. This is not the body. And another, you have to study the condition of equilibrium of body, that we will study in the rotation chapter. The torque we will study, and then after we will deal with the condition of equilibrium of body over there. This is called the condition of equilibrium of particle. A particle will be in equilibrium if net force is 0. So this is very important. If net force is 0, then the particle is said to be in equilibrium. Equilibrium, it means the net force on the particle is 0. Remember, it is not necessary if this sigma fz is 0, necessarily the sigma fx will be also 0. It is not necessary. Might be the particle having the sigma f, that is the sum of the forces along the z-axis is 0, but that particle is not having the net force along the x-axis as 0. It might experiencing some force along the x-axis, okay, despite of having the net force along the z-axis, it is 0. So, but in short, I have written sigma fx is equals to 0, sigma fy equals to 0, and sigma fz equals to 0. Here, using this particular mathematical form, my dear student, you can draw the statement of this particular law also, okay? Although I haven't taught you the Newton's second law, okay? But you know, you have studied in standard 9th about this Newton's second law. So let me use that second law to explain the statement of this first law, that we can draw the first law from this Newton first law. You can also say the Newton second law using Newton first law. Even you can draw all the laws from Newton's second law. Remember, you can draw all the laws from Newton's second law. What is that law, my dear students? Newton's second law. Actually, try to recall the equation of Newton's second law only, nothing else. It was sigma f is equals to mass times acceleration. If you are studying the force along the x-axis, the acceleration will be also along the x-axis. Remember, the direction of force studied with the direction of acceleration. The direction of force studied by the direction of acceleration. Now, sigma fx equals to max. My dear students, suppose if this sigma fx is 0, then max we can write, and we know that mass cannot be 0. It means acceleration along the x-axis will be how much? It is 0. And if acceleration is 0, my dear students, if acceleration is 0, then velocity will be what? It is constant. If the velocity is constant, then you can draw the two things from here. If any body moving, velocity constant, it means u equals to v. Suppose if any particle is in rest, alright, so according to this one, what will be the final velocity? It will remain in rest. If any particle is moving with 5 meters per second, what will be the final velocity? According to this one, it remain in motion with the 5 meters per second. And this was the statement of Newton's first law. If any body is in rest, it remain in rest. If the body is in uniform motion, it remain in uniform motion until unless net force is 0. That is, until unless any external force is not applied. So you can see we have drawn from this one, the net force is 0. So we draw from this mathematical explanation the statement of this Newton first law. Okay, my dear students, after knowing this thing, we can have the concept of point object and the free body diagram. Concept of free body diagram. So give the heading, my dear students, free body diagram. Actually, we use this concept of free body diagram to solve the question of mechanics in easy way. Okay, here the free body, it means we have to free all the bodies of the system. If in a system there are more than one body, the two body, three body are in contact, then we have to free the bodies. Okay, but how we have to free the body, try to understand. Suppose, my dear students, I'm having a body over here over my palm. Okay, if I'll just remove the palm, what will happen? This box will fall down. But the concept of free body diagram actually telling you to specify all the forces which is acting over this box. Okay, specify, that is represent all the forces acting over the box. Because of that, that box is not falling down. I will remove my palm, that is the surface. I have to show this surface as well as this body. Alright, but applying all the minimum contact forces that was acting earlier over this body so that it was in equilibrium. Alright, yes, look at here carefully. If this box is kept over this palm, which force is acting? I think you can guess the weight of this box is acting over my palm. Okay, and as it is acting its weight over the palm, palm will apply a normal force over this box. Okay, in this way we used to represent the free body diagram. Look at here, it means free all the bodies of the system without changing its state of equilibrium. Alright, this is the concept of free body diagram. My dear students, suppose here you are having an object of mass m, it is kept over the surface, to the rough surface. Could you guess how many forces are acting here in this system? So you can write all the forces. Remember, students, to study the concept of mechanics, you have to remember few things. Okay, and this is the concept of SAPHI. You have to solve all the question of mechanics with the SAPHI. Okay, SFFAE. Here S stands for system analysis. Okay, system analysis. F stands for free body diagram. Free body diagram, FBD. This F stands for force analysis. Force analysis. Remember, if you will not use any of the component of this SAPHI, might be that you can solve the question, but you can enhance your concept of solving mechanics problem using this SAPHI. You have to solve all the question with this SAPHI. Okay, so force analysis, A, it is the axis fixation fixation, and finally this E, it is the equation writing. Okay, my dear students, so you have to show the suffice while solving the question of mechanics. System analysis, what does it mean? System analysis, it means whether the system is in equilibrium or not. Okay, if it is in equilibrium, then you will apply Newton's first law. If it is not in equilibrium, then you apply Newton's second law. So the system analysis means to find whether the system is in equilibrium or not. The second, free body diagram. The free body diagram we have studied right now. You have to free all the bodies of the system by applying the minimum contact forces so that system remain in former condition. If it is at rest, it should be in rest. If it is motion, if it is in motion, then it should be in motion. You can apply this free body diagram to all type of bodies if it is in motion or if it is in rest. Okay. Force analysis. You have to see how much forces are acting, from where and where the forces are acting. So the force analysis. A. Axis fixation. You have to fix the axis by applying your IQ so that you can solve the questions easily. Okay. Basically, we used to fix the positive axis. Remember, students, the very important thing I'm dealing here. We used to fix the positive axis in the direction the body is moving. If we'll do the argument why we cannot put negative axis, I will say simply you can put, my dear students, but that will torture you later on. So put the positive axis in the direction in which the body is moving. If body is not in motion, then you can put positive axis or negative axis in any direction. It is totally not dependent. Now the E, the finally E, it is the equation writing. The equation writing, it means you have to write the proper equation for if the system is in rest, that is you are applying Newton's first law, then you have to write the sigma fx equals to 0. If body is in motion, then you have to apply sigma fx equals to max. Alright, after studying the linear momentum, we will study about the Newton's second law. Okay, my dear students. Now, let me discuss few questions on the basis of this free body diagram and understand what is the free body diagram. Okay, from next lecture, my dear students, I will teach you in very detail about this chapter, the Newton's laws of motion. Okay, so kindly write down this suffice. Okay, now let me discuss here the concept of free body diagram. Alright, this was the body of mass m. Here it is kept on the horizontal surface. Okay, now we are going to free this body and this surface as well. This is the body and this is the surface. You cannot imagine this body remain in air. But what are the forces acting? Here the one force, it is weight of the body, mg. Remember, the first force you have to represent is the weight of the body, and this weight should be parallel to the edge of your copy. Remember, whatever may be the orientation of the body, weight should be in this direction. Suppose if the body is kept on this wedge, okay, of mass m, so you have not represent the weight in this direction. Weight should be always downward. Okay, my dear student. So this is the direction of the weight. Here the weight. Of course, this weight is going to act over the surface. Am I right? Yes. This weight is going to act over this surface. It is raining so hard, my dear students. Here, this weight is act over the surface in terms of N. Suppose our contact force, it is N. Of course, this surface will not leave the body. If the body is applying the force according to Newton's third law, this surface will also apply some force over this body, and this will be the same. It is N. Alright, now we got the complete free body diagram. This is the free body diagram. In SAPI, we study the first system analysis. Yes, we have analyzed that the system is in rest. It is in equilibrium, static equilibrium. Alright. F, it is the free body diagram. We have made the free body diagram. You can see there is no contact of this body with the surface. If you will train, my dear students, without doing the free body diagram, directly you can represent the forces, and that will be your free body diagram itself. Alright? Yes. Now, force analysis. We have analyzed the force. There is no more forces acting. Now, A, the axis fixation. Since this body is in rest, you can apply the axis positive or negative in any direction. So, here the force is acting over y-axis only. So, this is the x-axis and y-axis positive. And finally, E, this is the equation writing. Since the body is in rest, we will apply the Newton's first law. We have studied only Newton's first law. That's why I am going to read here the Newton's first law. The questions involved with the Newton's first law. Here the sigma Fy, it will be 0. Yes, sigma Fy, the net force over the y-axis is 0. How many forces are acting over the y-axis, over the body? Remember, this will be your free body diagram, and this is the reference body diagram. This is the reference body diagram. Alright, so you have to study the force over this body only. Remember, while you are making the free body diagram and representing the force, do not make the force line like this one. Do not make the contact with this surface. You will be confused whether you have to take the force from this surface or you have to take the force over this body. So make the separation of this forces. Now you can see over this body only two forces are acting. One, normal reaction, it is in upward direction, and another, it is the weight which is acting in downward direction. Okay, my dear students. So the two forces are acting. If we have been taken the positive axis in upward direction, then this normal will be positive force. We have to add all the forces. It is a sum of. Okay, we have to add all the forces. Now here the mg, the second force, but it is acting in downward direction, so it will be the minus mg, and how much? It is 0. We can write m is equals to mg, and this is our answer. I hope you understand. Okay, one more question, my dear student, and then I'll give you question for your homework. Or let me give you the homework. We will start our lecture, next lecture, from this question. I'm giving you the homework. If you can do this homework, that's good. The homework. Make the free body diagram, and this is M1 and this is M2, and a force is acting here, F1, over the M2. You have to draw the free body diagram, and you have to find normal reaction on M1 and M2. You have to find normal reaction, or simply you can write find force on M1 due to M2. Okay, you have to find the force on M1. Here what we can write, the force on, if I want to write the force on here in this question, force on M by ground. Okay, the answer will be force on M by ground, it is N. This will be the answer. Alright, so you have been asked find force on M1 due to M2. And the second question, force on ground due to M2. Alright, how much force is acting over the ground by M2? Remember, M2 will take this force also and the force of this one also. I'm not asking the force individual by M2 actually. The net force acting by M2 over the ground you have to find. Okay, my dear students. So this is all about the today's lecture, my dear students. Thank you very much.